Hello, class. This will be our walkthrough of the full review for exam two. Um, I'm not going to work every single problem in there. I'm going to hit some of the highlights. Um, and then, I'll definitely hit the things that are most missed on this exam. And so, remember, in general, it, to be successful on this test, you have to know your definitions and your symbols. If you do, then it's typically a straightforward test. If you don't, there's going to be a struggle. So just the other general thing is this test is about a third of the algebra stuff. So the inequalities, the exponents, scientific notation, that's about a third of the points. Another third of the points is from 2.3 and 2.4 when you do your set of operations and your Venn diagram stuff. And the other third of the test is mainly definition stuff from 2.1, 2.2, and some of the survey problems in 2.5. So, all right, so let's get into MATLAB. Start looking at some of those problems. And then as I need to, I will jump to my video camera and work some of the problems. And just remember, in general, I highly recommend that you take this mini review, give yourself about 30 minutes, take it as a test. And when you're taking it, you are allowed one side of one page of notes for this test. And so anything you're missing on the skill check quizzes or this mini review, you should probably make a note to yourself on that one page of notes that you're getting. So, that's how you use that to study. And the reason I'm only giving you one side of one page is I want you to actually use that as, learning to study. It's basically the way I think of it. So, this is not an open book test. It's more like a condensed notes on like what you need to know sort of thing. All right, so let's get into the full review. So first couple of questions are going to deal with, again, that the content goes in order we covered it. So it's going to start with the inequality stuff. I always like to start the test if I can with sort of a warm-up question. So the graphing is definitely a good warm-up. And so, we now talked about set builder notations. This is the set x such that x is less than -3, which the important part is x is less than -3. So when you're graphing, you have to know two things. One is, which direction to go. And then two, are you using open circles or closed circles on your numbers? So hopefully you're good now with the fact that if x is less than, it's to the left. If x is greater than, it's to the right. And then open circle, closed circle. If there's no equals, we use open circle. If there is an equals, we use a closed circle. So x less than -3 is going to the left. So it's one of the top two. And then there's no equals. So then it would be B, B, no. Okay, so that's your warm-up question. Right. So a couple of those for practice. Yes, I'll leave it. Oh, I gotta change the mode on this. Let me need the. I'll be right back. All right. Sorry about that. Since the full quiz was a bit long, in MATLAB, there's a setting like you can save it for later. But for some reason, save it later doesn't let you skip around. You have to like answer every question. So I fixed it. So if you are looking at the full review for practice, and you don't get it done all at once, you can just X out of the quiz or out of MATLAB, and then it'll let you get back where you started. So. All right, so back to inequalities. So when we're graphing, so now this is a compound inequality. So -3 is less than x, which is less than or equal to 3. So when you have a compound inequality like this, you're not going to go forever either in positive or negative infinity. You're going to be in between two numbers. So we're going to be between -3 and +3. And then, since it's matching, see, open circle on -3 and then closed circle on +3. And so they can be different. So this one would be B. All right, and then you got a couple more of those. Okay, so you're definitely going to have to be able to solve these. And so when you're solving, the thing to remember is, other than one exception, the solving process works exactly the same for inequalities that it does for equations. The one exception is if you get down to the end, if you divide or multiply both sides by a negative, then you do have to reverse the inequality. Greater thans become less thans and vice versa. All right. So let me work this one out right quick. Okay, so this is what we're trying to solve. So that is 3x minus 3 is greater than -x plus 13. All right, so again, just like equations, figure out which side you want the variable on. If you always get the variable to the left, then you don't have to worry about the graphing being in the wrong direction because you're reading it from left to right. So that's what I like to do. That. So, again, we're just isolating a variable. We're getting all the x's to one side and then all the constants to the other. Yeah, so none of this is any different than we did in Unit 1. Yeah. Now, down here at this last step, if that had been a -4x and we were dividing by -4, then the greater than would have became less than. But remember, you only reverse that inequality if you're dividing by negative. So this is pretty much at the last step. If you're doing that, that's when that would get reversed. It doesn't in this case, so we're good. Okay, and so when you are, go back to MATLAB. Right. So notice when you're typing in the answer, it says type in an inequality. Now, if it was an equation, we wouldn't need like the x equals 4, but it's because of the inequality, we do have to put the whole thing. And the greater than and less than are on your keyboard. Hopefully you've done your homework, so you've seen this before, but it's been a couple weeks. But don't forget, if you want the greater than or equal to's, then down here at the bottom in the button palette is where those are. And oh, I forgot to go. Okay, and so now the advantage of having x on the left is x is greater than 4, so greater than is going to the right. And then there's no equals, so it's that one. And when in doubt on which direction to go, I always like to plug in a number on either side and see which one makes sense. If I plug in like 0 greater than 4, well, 0 is not greater than 4, so I don't go that direction. But if you go on the other side, 6 is greater than 4, so that's good. So I won't go. All right, so that's if I get stuck on which direction, plug in a number, see what makes sense. So the other type of inequality we have is a compound inequality. And so what is the goal on compound inequalities? The goal on compound inequalities is isolate the variable in the middle. So whatever you do to the middle, you got to do to all three sides. Okay. This one's pretty straightforward. We need to add 11 to zero that out in the middle. So we're going to add 11 to the left, to the middle, and to the right. So negative 12 plus 11 would be -1. And then it's less than or equal to, so go down here, get that. Is x, which is less than, and then 1 plus 11 is 12. Right. So I'm not going to work that out on the paper because we're just adding 11 to all three parts. Now, if that had been like 2x minus 11, then at this point, I would have divided everything by 2. So divide the left, divide the middle, divide the right. So when you're solving compound inequalities, goals, get the variable in the middle by itself, solve it just like you always do, just now 3 parts instead of just 2. And then to graph it, well, there's, -1, so it can't be D or B, because those are going to like -12s. So if you look at A and C, closed circle on the left, open circle on the right, so it'd have to be C. All right, so that is your inequalities. All right, then we get into our exponents. Okay, and so you have to be able to do these with both numbers and number bases and variable bases. We spent probably more time on this in class than I do on the test, mainly because this is more of a college algebra prereq, and so we don't get too messy on this. So the one thing, if you have a number base, pay attention to the instructions. This top one says type of exponential notation with positive exponents. The bottom one says type a whole number. Now this one says simplify the exponents with exponential notation. This one says evaluate. So when it says type exponential notation, that means we need a base and we need an exponent. So I have a base divided by a base. So what do you do with the exponents? Well, that rule is you subtract the exponents. So we're doing 6 minus 3, which is 3. So that would give us 5 to the third power. Okay. Now, don't put that in your calculator when it says type exponential notation, because we need the base of 5, we need the exponent of 3. Now, when it says evaluate and type in a whole number, that's when you put in your calculator. So 5 to the third would be 125. So that's what they would want there. So numerical bases, we're going to do half the problem with what are your exponent rules, and then half the problem of what is that actual number. Okay. So then there's a couple of different ones here. So when you have the same base multiplied, doesn't matter if the bases are numbers or variables, you're adding the exponents. And so don't let that negative exponent like throw you off, because once we add them, we're gonna do 7 plus a -4. So that would just be 6 to the third. The only time you really have to flip, when negative exponents mean a flip, so that, if we just had 6 to the -4th, that would be 1 over 6 to the +4th. But I wouldn't do that at first, because once we add those exponents, the negative exponent goes away, so we don't really have to worry about the flip. All right, or you could flip it and make it 6 to the 7th over 6 to the 4th, and then it would end up being just like it would make it a division problem instead of a multiplication problem. Okay. But again, when the type says type exponential notation, we need the base and we need the exponent. And then for that evaluate, I'd plug 6 to the third in the calculator, and that comes out to 216. All right. So here is a good test question that kind of does multiple rules. I'll do this one on paper. We have 60 b to the 5th, c to the 3rd, over -10 b to the 8th, c to the -13. All right, let me bring up my document camera. All right, so when you're doing a problem like this, first thing I would do is I'd recommend splitting this up into 3 fractions, because we have numbers, we have b's, and we have c's. So I think if we split it up like that, then it makes it a little bit easier to deal with. Then we're just dealing with, like one set of rules at a time. All right, so remember with your numbers, just, note that's a 60 over -10. So 10 goes in 66 times, positive divided by negative is negative. So that gives us -6. Okay. Now over here, for the b's, we're doing the exponent rule. So when you divide, you're subtracting. So 5 minus 8 is -3. B to the -3. Now, we're not done here, so let me go and finish with the b. And so when you have a negative exponent, that does mean we're going to flip it down. Anything that is over 1. So that would be 1 over b to the third. Now, the other way that you can deal with that is I kind of use what I call a common sense subtraction rule. And so up here, when I'm dividing, I'm still going to subtract the exponents. I would do 8 minus 5 is 3. And then where are most of the b's? Most of the b's are in the denominator. So they're still going to be in the denominator. So that's that's how I would kind of do it, but I've been doing this a while, so I'm comfortable with that. Yeah. Now let's deal with the c's. Okay. Now over here, let me do this on the side because if you use the division rule that says you're going to subtract the exponents, you have to be careful because that would be 3 minus and then a -13. So there would be a double negative there. So that would be c to the 3 plus 13 or c to the 16. Or the other way that you could do this is if you don't like having a negative exponent in the problem to begin with, that term, that's the only term, has a negative exponent, we could flip it to the top. So it'd be c to the third times, now it becomes c to the positive 13. And then we have the same base multiplied, you add the exponents, gets us right back to c to the 16. Okay, and then since we have a fraction, these over 1. So on top we have -6, c to the 16th, b to the third on the bottom. Oh, and one thing I noticed, and I'll give you full credit on this, I think this is the problem where whoever coded this problem in MATLAB, we've talked about this before. If you have a fraction with one negative, it doesn't really matter if it's in the top or the bottom or out front, because overall it's all negative. But for some reason, whoever coded this problem counted it wrong to put the negative in the bottom. But positive divided by negative is still negative. But like I said, any problem you miss on the test, I will go back and look at it. So that is our exponent rules. Yeah. So if you have the same base multiplied, you're adding the exponents. If you are dividing your variables or your bases, you're subtracting the exponents. And then negative exponents mean you have a flip. All right. So that's already okay. So then you're going to get into scientific notation. They're going to have to convert to standard or decimal form to scientific notation and vice versa. So go both ways. And so the thing to remember is scientific notation. The general format is, it's the decimal is to the right of the first non-zero number. So in this case, it would be 5.4. And then you're going to have some times 10 to some power. And the power itself is determined by how many places you move the decimal. So in this case, we're going to put the decimal between the 5 and the 4. It moved 1, 2, 3, 4, 5, 6, 7, 8 places. Okay? And so the other thing you have to remember on the exponent is either positive or negative. If it's a big number, larger than 1, exponent is always positive. If it is a small decimal number less than 1, then exponents are negative. So this would be 5.4 times 10 to the positive 8. And if you can remember that, large numbers have positive exponents, decimal numbers have negative exponents, then you don't really have to don't have to memorize which way to move the decimal, just move it the way that makes sense. All right. So here is a decimal number. So again, the decimal is going to go to the right of that one. So to get it there, we had to move 1, 2, 3, 4 places. So that would be 1.4 times 10, and now it's -4 because we're dealing with as the exponent because we're dealing with decimal numbers. Yep. So now you have to go backwards. And so this is 8.23 times 10 to the fourth. We want it in decimal notation. And so you have to, you have to know since it's a positive exponent, we're dealing with large numbers. And so which direction do you move the decimal to get a large number? Well, if you move it to the left, you're getting a decimal number, so you move it to the right. So you move it 2 places to put it in front of the 3, to the right of 3, and then you gotta move it 2 more places to get to the fourth. So that would be 82300. 82300 would be 82,300. All right, and then 4.96 times 10 to the -4th. Now it's a negative exponent, which means we're dealing with decimal numbers. And so we're going to move that decimal to the left to get a decimal number. 1 place moves it to the left of the 4. Now we need to move it 3 more places. So it's going to be 0 point, and then 3 zeros, and then 496. And remember, we're not counting that 0 to the left of the decimal. That's just there for, I don't know, for me, it makes it easier to read the decimal. Okay, and so you're going to have some conversions back and forth, and then you're going to have either a multiply or a divide problem. Okay, we talked about in class, doing it by hand. Like the most common way to do it by hand would be convert it to decimal notation first, which in this one it wants the answer in decimal form. So if you want to go to decimal form first, then you don't need to go back to scientific notation. That would be, that would be a large number. 3 followed by 9 zeros, that would be a small decimal number, and then you just do the calculations in your calculator. Or you can do, if you're going to, the reason we're doing this is for chemistry folks next semester. So chemistry instructors are okay with doing it on the calculator. So if you know how to plug this into your calculator, that is also acceptable. Let me do a refresher of that right quick. All right, so for these calculators, when you're multiplying and dividing, parentheses are important with the scientific notation. So we have 3, and then this one has a times 10 to the n button. So 3 times 10 to the 9th. Different calculators are, if you're not using one of these, then make sure you know how to use your calculator. And then times 3 times 10 to the n. And now we want a negative. And when you do your negatives, make sure to use your negative button, not the subtract key. Oh, and I didn't mention it before, but if you notice, I moved my cursor because when you do that exponent, your cursor is up there. You need to move it over so that your parentheses is at the end. So there's your answer. And this one's in decimal notation. So that is 90,000. If they wanted the answer in scientific notation, then you would have to convert this to scientific notation. So that would be 9 times 10 to the, to the 5th, because we moved the decimal 5 places. So make sure you're reading your instructions on these problems. Sometimes they want it in decimal notation, sometimes they want it in scientific notation. That's why we did a couple other problems where we were converting as well. So if you're dividing, notice that they didn't put parentheses around here. To make sure you get, again, I'm leaving it up to you on your own calculator to figure it out, but for these calculators, you either have to use parentheses around the 6 times 10 to the 5th and the 3 times 10 to the 6th if you use the divide button. But if you use the fraction button, the N over D button, it already sets it up like that. You don't need parentheses because it's understood to have parentheses if you're using the fraction button. But make sure on both of these that you know how to multiply or divide scientific notation. Okay. Then we get into chapter 2. First part of chapter 2 is 2.1 and 2.2. So it's a lot of definitions and symbols. again, hopefully you're using your quizzes and taking them like without looking at any notes. That way you know what you miss. And so if you're missing any of these things, then make notes to yourself. All right. So here's a typical question. Express the set using roster method. Set X such that X is a lowercase letter of the alphabet that follows S and comes before Y. All right, so we talked about this multiple times. Well, I've talked about it in my in-person class a lot of times. You've encountered this on your own as you're doing the homework. The real key is, do we include the endpoints? So are S and Y going to be part of these letters? Well, since it says it follows S, that does not include S, and it comes before Y, so we don't include Y. So when I'm looking at this, it can't be A or B because those both include S. Okay. And then when I look at C, it might be C, D includes Y, so it can't be D. Okay. And there are definitely letters between S and Y, but it's not E, so it would be T, U, V, W, X. So a lot of these type of questions, it really comes down to are you paying attention to your endpoints? Okay. Roster method lists the set of natural numbers less than 7. Well, what are natural numbers? Hopefully by now you're comfortable with those, the fact that those are the positive, the counting numbers, 1, 2, 3, and so on. They already put the brackets for you, so you don't need the brackets. Now, normally we talk about roster method, order doesn't matter. However, read your instructions, because sometimes MATLAB will put that in there. So ascending order means from smallest to largest. Descending order would be largest to small. So if we're doing natural numbers, less than 7, the smallest one is 1, and then 2, and then 3. Now, don't put your dot, dot, dot. Like if I was doing this without MATLAB, I would, you feel free to use dot, dot, dot. But here in MATLAB, they want you to list them all out. And I'm putting periods instead of commas. Yeah, and then if you do stuff like periods instead of commas, like I was trying to do, I might take off like half a point. To me, that's sort of like an arithmetic mistake. Right. And then it says less than 7, so it definitely does not include 7. You would have to say less than or equal to 7, or it could say like less than 7 inclusive. Right. So again, watch for your endpoints. Okay, set of even natural numbers less than 6. So less than 6 means no 6. So it can't be D. Can't be B because that's odd. Can't be A because those are greater than 6. So sometimes with multiple choice, you don't, sometimes you can figure out what's the wrong answers. Sometimes those might be easier than the right answers. So, and on any of these questions, I know there's not much work to show, but if it's like a true and false, if you like write down on your paper why you chose true or why you chose false, that would be something like, because something happens a lot of times with true and false is people get it wrong, but like they'll explain the concept on what they chose correctly, but then they just chose maybe the wrong concept. So things like that might be, like half credit or something. So if you start with a bad premise, but if you make good points from there, if I can see that, then I can give you credit. But if you're just saying like a true or false, then and that's it, then it's either right or wrong. Okay. So again, being able to read this, so that's X is an element of that capital N is the natural numbers. We want 4 to the 7. Now we're including the 4 and not the 7. So B is the only reasonable choice there. Okay. So a lot of this is what the 2.1 questions look like. So here's a true and false. 33 is an element of the set X such that X is a natural number. Well, that's a natural number, so we're good so far. And 23 is less than X is less than 35. So is 33 in there? Yes, because that's 23 through 34. And you can even write that is like the set is the set is 23, 24, 25, dot, 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 up to 34. That would be how you show your work on a true or false question. Okay, equal and equivalent. Again, this comes down to knowing your definitions. Equivalent sets are sets that have the same cardinality, the same number of elements. Equal sets is stronger because not only do they have the same number of elements, the same exact elements. Okay. So when you look at A is 3 9s, 10 10, 3 11s. B is 11 10 9. So are they equivalent? Well, if you look at it and say no, because the top A has 8 elements and B has 3, then you're overlooking the fact that when we're talking about the cardinality, the number of elements, it's distinct elements. So A only has 3 distinct elements because we're not counting repeats. B has 3 elements, so those are equivalent. And so the sets are equivalent because the cardinality of A is equal to cardinality of B because they have the same elements. Now, are they equal? Well, if we're ignoring repeats, A is 9, 10, 11, B is 11, 10, 9. So are those equal or not? Yes, because order doesn't matter in a set unless MATLAB asks you to. So the sets are equal because set A contains the same exact elements as set B. Okay. So again, if you know the definitions, that's a straightforward problem. If not, that's I can say that about a lot of this test. Okay. Same idea, except now they don't give you the sets. They give it to you in roster notation or set builder notation. So the first thing I would do on this is what is the top set? What is the bottom set? Okay. Let me do this one on the paper. Because again, this is how I would show my work on a question like this. A lot of people tend to score lower on this test than they probably need to because they don't write anything down. Which, if you're getting them right, that's great. If you're not so good. The partial credit always has ability to add up. Okay, so if I'm going to list out X is 5 is less or equal to X, which is less than 8. So the equals means we're including 5, so that would be 5, 6, 7. Now we don't include 8 because there is no equals. So that would be A. B is the set X such that 6 is less than X, which is less or equal to 9. So if I write this out in roster form, there's no equal on the 6, so we're not including 6. It'd be 7, 8, and then we're equal on the 9. Okay. So first of all, are these equivalent? Yes, because A has 3 elements, B has 3 elements. These are equivalent. Okay, but are they equal? No, because they are definitely different sets. This one has 5 and 6. This one has 8 and 9. Okay. Again, pretty typical problem for this from 2.1. All right. Let's go back to the quiz. Okay, so here's my number 25. And again, this is where you have to know the symbols as well as the definitions. So you see the little C with the equals under it. You should know that's a subset. And again, if you're iffy on this at all, you're getting that 1 page of notes or one side of 1 page. So that's the sort of stuff you should put down. So is it a subset or the /3 means not a subset for the resulting statement? So what is the definition of a subset? It's every element in the first set is an element in the second set. And the equal says they could be equal. So is 2 over here? Yes. Is 7 over here? Yes. Is 3 over here? It's in the ... but yes. So therefore, it is a subset. If that was like 2, 7, and then 13, well, 13's not over here, so then it would not be a subset. Okay. So like this one. So -7's there, 7, +7's there. But if it gets 0, 0 is not over here. And be careful, there is no dot, dot, dot in there. So that one is just those 4 elements. So since 0 is not in the right-hand side, this is definitely not a subset. All right, and then determine whether that's a regular subset, a proper subset. Remember, proper subset cannot be equal. They are subsets, but just can't be equal. And then both or neither. Which, to be honest, I kind of have a problem saying both, because if it's a proper subset, by definition, it has to be a subset. So if it is a proper subset, then it actually is both. All right, so I kind of wish they didn't say both, because you can't only be a proper subset. If you're a proper subset, it's both. So to me, that's sort of like a misleading choice. So first of all, is a subset. Is every element in the left and the right? If not, we're done. B, V, C, and C, M, and M. So it's definitely a subset. Now, is it a proper subset? Yes, because this is not equal to the other set. So if they're not equal, if the left set is smaller, then we're both subset and proper subset. Okay. Calculate the number of subsets and number of proper subsets. And so this is one of the few formulas that you had. So you might want to make sure that's on your formula sheet. The number of subsets is 2 to the n. The number of proper subsets is 2 to the n minus 1, because they can't be equal. So we have to take that one set away that's equal. So how would you do this problem? If 8 is less than x is less than 13. So again, how do you show work on this? Well, first of all, what is your set? Well, I always like to do this in roster form. And so we're not including 8, we're not including 13. And so this would be 9, 10, 11, 12. Okay. So if we want the number of subsets, that is 2 to the n. And what is n? Well, n is anything in chapter 2. If you see a lowercase n, that's the number of elements. We're talking about, cardinality. So there are 1, 2, 3, 4. So n is 4. Now, if you wrote that out and you got the wrong number of elements, but did this right, then again, that's where I can give you partial credit, sort of thing. Like if you had included the 8 and 13, you would have had n at 6, and your numbers would have been too big. Okay. But now, this is just 2 to the 4th, which is 16. And then the number of proper subsets. They can't be equal, so we always got to subtract 1. That would be 16 minus 1 is 15. Again, if you know what the formula is and how to use it, that's a straightforward problem. If you don't know this and you don't know what n is, then we can't even start the problem. All right, so that is 2.2. Here's another version of this. Same idea, but now it is equal to. So if you're writing out the sets, you'd start at 4, end at 7. And so that would change, so 4, 5, 6, 7. Well, in this case, it'd still have end of the 4. So this would have the same answers, because it'd be 2 to the 4th again. So that would be 16, and then that would be 15. You're always subtracting 1. All right, so that is 2, 1, and 2, 2. It's all your definition stuff. Then we get into what I consider like the meat of this test is the 2, 3, and 2, 4 stuff. This is when you're doing all your operations and your Venn diagram stuff. So you have to know, when you look at it, what is that symbol? Is that intersection? Is that union? What does it mean? Well, intersection is just the elements that are in both sets. So in this case, it would be 1 and 2. And notice they already put the brackets there. So you just need 1, 2. If this was the union, it would be the regular, straight up U. Union is basically everything in the first one as well as everything in the second one. And anytime I'm doing union, I just list everything in the first set. So I would list 1, 2, 5, 6. Then I would list anything in the second set that I haven't already listed. So I hadn't listed 4 yet because 1 and 2 would already be. You've got to know the difference in union and intersection for this test. Oh, here's the union. So, so the way I would do A union B is I would do 2, 3, 4, 6. That's A. And then I would go to B, list anything that I haven't listed. I don't have a 1 yet. I already have the 4, so I don't list it again. And then I don't have the 5 yet. So it'd be 2, 3, 4, 6, and then 1 and 5. And notice that it doesn't say anything about putting it in order. So, I mean, I kind of like having these things not in order because that kind of tells me like where you got the numbers from. But it's your choice of putting it in order. All right. So a lot of people miss this question because that apostrophe is an easy thing to miss. And either they totally miss it or you don't. I think if you're not looking for it, it's easy to miss. But that is one of your 3 operations. So you need to be looking for these apostrophes. And what does the apostrophe mean? That means a complement or not a. And anytime we do complements, you always go back to the universe and take out everything that's in the original set. And what's left over is your answer. So a complement would be not 13, not 14, not 15, not 18. So a complement would be 16, 17, and 19. So complements or a knots, always go back to the universe. It's what's left over after you take that set out. All right. Now, once you start doing more than one interaction or more than one operation, please write these down, like each step. Because these get missed all the time. And if you don't write down like your first step, then I don't know, if that's what if you just give me an answer, it's almost impossible for me to figure out why you got a wrong answer unless you give me like the most common wrong answer, which means no partial credit problems like this. And again, having partial credit versus not having partial credit can make a big difference in grades. Okay, so this is A complement intersection B complement. This is number 33. Okay, so when you have multiple operations to do, which one do you do first? Well, when in doubt, go by order of operations. So you have grouping symbols, you have exponents, multiply and divide, add, subtract. So grouping symbols is parentheses. There are no parentheses, so there's none in this problem. Exponents, complements work like exponents. So exponents are going to be the highest order on this. And then intersection and union, to me, works like add and subtract. I don't think you really look at an equivalent of multiply and divide. It's not that we're doing. So step 1, you got to do your exponents or your complements. And so you need both of these. So it doesn't really matter which one you do first. Let's call this step 1 is A complement. Skip a spot and do B complement. All right. And so how do you find complements? Start with your universe. Universe 1 through 7. And now A complement means we're going to cross out anything that is A. So A is 2, 3, 6, and 7. So a complement is what's left over. So 1, 4, 5, and that's it. And then if you have more than one complement, do yourself a favor and just write out the universe again. Take a little bit of extra time. Because if you try to come up here and cross stuff out again, then it's, especially if you're not using different colors, then it's real easy to get off track. All right, so B complement, we don't want 3, we don't want 5, we don't want 6. B complement is 1, 2, 4, 6. Okay, so we took care of the complements. Now we got to do the intersection. So the first set is 1, 4, 5. We're intersecting that with the second set of 1, 2, 4, 6. And now you got to know intersection means only what they have in common. So it's 1 and 1, 4 and 4, and that's it. So A complement intersection B complement is 1, 4. And that is how you would fully show your work for a problem like this. And remember, if you're going through here and you're getting an answer that has no elements, that is the empty set, which on problems like this, there's like an A, here's the answer, and then B, it's the empty set. So if you get no answer, it is valid, it is a valid answer with sets because we have the empty set. Okay, so like here, since we have specific elements, we list 1 and 4, but if we had come up with nothing, then we would have answered the empty set. Okay, so this one's the same idea, only now we only have one complement. So let me this one as well. Seven, 6, 14, 16, 10, 20. So that universe is not in any order whatsoever. But we only have one complement here. So again, since there's no parentheses, next thing we do is the complement. So step 1 is going to be our complement. And then step 2 will be the union. Okay, so let me get this wrote down, and then I'll show you. 7, 6, 16, 10, and then A is 9, 20, 2. Okay. Okay, so we are doing A union C complement. All right, so that means first step is do our complement. All right, so since we're only doing one complement, I only need the universe once. So I don't want 7, I don't want 6, don't want 14, 16, or 10. That means C complement is 9, 20, and 19. Okay. So that's the first step. Okay. Now we do the union. Remember, union is everything. So it's everything in the first set. So that is 9, 20, and 19. So we've taken care of everything in A. Now we need to union that with C complement. And so we have 9 already, we have 20 already, we have 19 already. So we don't have to list anything again because everything that's in C complement is already there. So there's no new elements to add. It's just, they both have the same elements. All right. So this is how I want to see on your page when you're doing more than one operation. Not only does it make it easier for me to grade, give you a chance for partial credit, if you write them out, you're less likely to make mistakes. All right. So that is without Venn diagrams. Now we can do the same thing with Venn diagrams. Okay. So use the Venn diagram to represent A intersection B complement. Write this out and then we'll discuss it. Okay, so You have to know how to read Venn diagrams. So intersections. So when you have two sets, the intersection of two sets is where they overlap. So the intersection, and I'm not working on the problem right now, I'm just talking in general. So the intersection of A and B would be this 2, 6 region. The union is everything. So it would be everything in A. So 4, 5, 2, 6, everything in B, 1, 7, 10. So the intersection is just the middle, union is all of it. And then stuff out here, remember the whole thing is the universe. The 915 is the stuff that's in the universe that's not in A or B. And then if you want to complement, then you basically cover up what you don't want, and it's everything else. So if I wanted A complement, it's not 4, 5, 2, and 6. Don't do that circle at all. It's just what's outside. So it'd be 1, 7, 10, 9, and 15. Again, like one thing is I like writing this down on paper. Like I said, I'd have a couple of quarters handy. Maybe show them to honor lock. You never know. All right, so let's see how to do this. So we have parentheses. So that means we got to do inside the parentheses first. So again, and what I'm writing down on my paper is, again, excellent way to show work on the test. So I recopied my Venn diagram. So step 1 is A intersection B. And so where is A intersection B? It is right there. I wanted to shade it, but I don't have a highlighter. All right, so sorry. So it's 2 and 6. So that is the intersection of those two sets. Now we do the complement of that set. So if you're doing the complement, now is where you just cross it out, cover it up, and then the complement is everything that's left over. So that's 4, 5, 1, 7, 10, and 9 and 15. This complement is everything in the universe except, in this case, that region. Like if I wanted A complement, it would be 1, 7, 10, 9, 15. If this was union instead of intersection, the union would be everything inside the circle. So it'd be 4, 5, 2, 6, 1, 7, 10. The complement would be everything but that. So the complement of the union would be 9 and 15. Right, so there's a variety of different ways we can ask these questions, even with a two-set Venn diagram. Again, this is how you show your work. Write down the first step, and then go from there. Oh, this is a union B complement. So that's what I was just talking about. They changed the numbers on us with the same idea. So do inside parentheses first. So A union B. So that would be everything inside the circles. And then the complement is the opposite of that. So it would not be inside the circle. So in this case, it would be just outside. So the 23 and the 17. All right. Now, what is the difference between this question and the last two? Because of that N. So if you don't know what the N is, and you're not reading the problem and understanding the instructions, the most common wrong answer on this, people would just tell me that Greek theta, and then they would like, well, they would go down here, and put that theta in and get it wrong. Okay, because you have to know when you see that N and then something parentheses, that's the cardinality, which it says right there in the problem, which means the number of elements. So we don't want the actual elements. I want to know the number of elements. So if I'm doing A intersection B, that's the overlap. There is one element there. So the answer is just 1. Yeah, if it was the number of A union B, that's, remember, union is all of it. So 1, 2, 3, 4, 5, 6. So then, but if it was the cardinality of the union, it would be 6. This one is the cardinality of a complement. Okay, so first of all, what is a complement? Well, you don't want anything in that circle. So it's not pound, it's not percent, it's not theta. Or is that omega? So it's not those three, it's everything outside that circle. So it's the stuff that's only in B. So there's 3 elements. And then that 17. So can I highlight it? Won't highlight 7, but there are 4 elements, 1, 2, 3, and then 4 that are not A. And again, if you write that down in your paper, me physically, I think it's really easy to like cover it up and see the complement. All right, so once we get these 3 set Venn diagrams, and now we've transitioned over to 2.4. Though we talked about this, again, I said we talked about it, but in my in-person classes and on my videos, that there are no new ideas with 3 sets, other than it's more complicated because there are more parts. All right, so you have to be more careful, especially with the intersections. And so if I ask you where is A intersection B, don't tell me it's just region 2, okay? Because if we're talking about A and B, ignore the circle C. So A and B is regions 2 and 5. Yeah. Region 2 is an A and B, not C. Region 5 is an A and B and C. But if I'm just asking you for A intersection B, I don't care about C. So for these intersections, it's what I call a trifoil. There's always 2 segments or 2 regions for when you're dealing with 2 sets. Okay, so which regions represent C? Okay. All right, if you tell me 7, you've just given me the most common wrong answer, because that is definitely in C, but it's not in any of the rest of them, so that is C only. If you want C, it's the entire circle. So it's 4, 5, 6, and 7. And yes, they do want you to use Roman numerals, so use I's and B's, capital letters with I's and B's. Again, if you're not using Roman numerals, I'll probably give you like at least 3 out of 4. But I think it's pretty common. We need to use Roman numerals here, and if you've done your homework, you've had practice with it. So like, where is B? B would be 2, 3, 5, and 6. A is 1, 2, 4, 5. So A complement. So we don't want A. We don't want those 4 regions. So what is anything that's not A? Well, it's 3, it's 6, it's 7, and don't forget 8, because 8 is out there, outside that circle. Okay. All right, so what regions represent A union B? So again, we don't care about C, kind of ignore that's there. So what does union mean? Treat this just like a regular 2-set Venn diagram. I want everything in A as well as everything in B. So everything in A is 1, 2, 4, 5. And then B, we've already done 2 and 5. We need 3 and we need 6. If it was intersection of A and B, it would be 2 and 5. What would A union C? Where is that? What's everything in A? Everything in C. So A union C would be 1, 2, 4, 5, then 7 and 6. If we wanted A intersection C, then it would be 4 and 5. Okay. So you're going to have some questions, again, where you're going to have to identify these regions on a 3-set Venn diagram. B intersection C, again, ignore A. It's those 2 regions, 5 and 6. It just so happens 5 also has A, but we don't care because we're not saying anything about A. I just want to know intersection of that circle and that circle. Okay, so now we have A intersection B intersection C complement. So you're going to have, same thing we did with 2 sets, only we're probably not going to get as messy with the 3-set Venn diagrams as we could. We'll save that we'll do more of the messier set operations with two sets. But let's see. This one's, so what do you do first? Okay. So inside the parentheses, it's A intersection B intersection C. So where's the intersection of all of them? It's right there in the middle. So since it's intersections, it would be just the 15 that we're not talking, that is the 15 is the intersection of all three. Then it wants the complement. What's the complement? Complement is everything in the universe, which is the entire box, that's not in that set. So it's everything except 15. And yes, you would have to list those out. So it starts at 1, goes to 19. So you would need to list all of those except 15. Notice it doesn't say anything about order. So like if I was doing this, I would just, I would do 1, 4, 5, 6, 10, 14. It takes care of A, and then I go here to, it doesn't matter what you do next, 8 and 9, 16, 17, and 19. Oh, they're missing. Oh, they're, okay. See, if you just listed everything 1 through 19, you'd have an extra one because there's no 2 and 3. See, I was getting in a hurry. So, yeah, so just list them like by region. We don't want 15, so we want all those outside 15 as well as the 19. If this was unions, remember union is everything. So if this was A union B, union C complement, well, the union is everything in A, it's everything in B, everything in C. So if these were all unions, that would be all of those circles. The complement would be just 19. That would be the only thing left after we unioned all those. Right, now I really wish I was doing this live, so that way I could be getting, oh, here it is, the union one. So yeah, so union of all of those is everything inside the circles. The complement is what's outside. All right. So now we're getting back into things we did before, except now it's 3 sets instead of 2. So what do you do first? You would do B intersection C. So I would go in on my paper. What is B intersection C? It's just what B and C have in common. B1 and 2. So that would be your first set. And then you would union. And so if you're going to union, let me write this down. 1, 2, 3, 4. There is no complement on this one, so I don't need the universe. So when you're doing your set operations, that's you're just dealing with the sets unless you do complements. This is B intersection C. All right. Document can work. Okay, so A is 1, 2, 3, 4, B is 1, 2, 6, C is 1 through 5. And so we're doing A union B intersection. Word of operation says we do inside parentheses first. So B intersection C. So B intersection C is what do those two have in common? Just 1 and 2. So now we're going to do the union. We're doing A union B intersection C. And so again, union is everything. So the quickest way to do unions is list everything in the first set. So I'm going to list everything in A. That's 1, 2, 3, 4. Then I go to the second set, which is 1 and 2. I already have 1 and 2, so we don't need anything new. So we're done. So that is how I show my work for a problem like this. And as always, if you have questions, since you can't ask questions in the middle of this, please email me. Remember, if you're doing your homework, you can do that. Ask my instructor. I've had a couple people, just email me other questions. So, all right. Here's 46 is one of the messier ones. Here we have a complement, so I need to get the universe down as well. share that while I'm writing it down so you can see it. All right, so this is, the universe is 1 through 7. And normally I would do the dot dot as well, but since we have a complement, I know I need all of them, so I'm gonna go ahead and write them out. A is 1, 3, 4, 6. B is 1, 2, 3. And C is 1 through 5. And what do we want? We want A union B complement intersection C. All right. Okay, so here are our sets. We want, so it's A union B complement intersection C. So where do we start? Order of operations says start inside the parentheses. So first thing is A union B. So union is everything of those sets. So list everything in A. So 1, 3, 4, 6. And then go to B and list anything we haven't listed. We already have 1. We don't have 2. And we already have 3. So the A union B is 1, 3, 4, 6, 2. So we took care of inside the parentheses. Now we go to exponents, which is our complement. So A union B complement means we go back to the universe and cross out everything that's in that set. So we don't want 1, don't want 3, don't want 4, 6, or 2. So what's left over is 5 and 7. Okay, so now we've done the union, we've done the complement, and now we got to do the intersection. Okay, so what we're looking at is this set complemented, or sorry, union intersectioned with that set. So what do these two sets have in common? Is there a 5? Yes. Is there a 7? No. And those are only 2 elements. So that's 5 is the only thing they have in common. So that is our final answer. And again, it would not be unusual for there to be anti-set. So like if this had been just 5, then if we were trying to intersection those two sets, there's nothing in common, our answer would have been the empty set. Okay. So problems, I see problems like this, like order of operations kind of start small and work your way up. So with set operations, we start small by like, what's A union B, what's A intersection C, what's C complement. And then these are like the long word of operation problems. If you can treat them as such, and if you know your definitions and how to apply them, hopefully it's going to be relatively straightforward. But again, you're learning a new language, a new style of math, and so sometimes it takes practice. And I'm particularly worried about the people who haven't been doing all their homework, because that's a lot to cram in just a few days. All right, so then we get into problems like this. I'm sharing screen, sharing it. Yep. Okay, so this is my 47. So now we're getting into like the survey problems, like the 2.5 problems. Okay. So using the accompanying Venn diagram, it shows the number of elements in region 2. So they already gave us the intersection to answer the following problem. So, and again, you got to know that's the cardinality of A, or the number of elements in A is 42. Number of elements in B is 43. The universe has 73. Find the number of elements in each region. So for these last few problems, the first thing you have to do, whether it's 2 sets or 3 sets, is you've got to fill out the Venn diagram. That's the key to this problem. And then once you fill it out, then you can answer the questions. All right, so what do they tell us? So we know the number of A is 42, relative B is 43, and relative U is 73. Okay. So how do we do this? All right, so step one, fill out your Venn diagram. In general, first step is almost always do the intersection, but they already gave it to us. So that's sort of like step one is done. And then you got to start working your way outwards. Okay? So here's the key concept on these 2.5 problems. Where does the 42 go? If you tell me 42 is in there, you've made the classic mistake of saying that that is A. That region one is not A. Those two regions are A. Yep. So so that means that there in that circle, there are 42 elements. We've already accounted for 19 of them. So how do you figure out how many are just in A? Well, you got to do 42 minus 19. And this is where your calculator, this is the the arithmetic of this unit is doing these subtractions. So there are in A, there's a total of 42 elements. 23 are only in A, 19 happen to be in A and B. So there's total of 42. But what do we do with that number of B is 43? Well, B is both of those regions. So there's 43 in those two. We've already accounted for 19. So that leaves 24 unaccounted for. So there are 24 in just B. So 24 in just B, 19 in A and B, total of 43. All right. Well, we're not done yet because we need this outside region. Right, so remember the universe is the entire box. So in the entire box, you're supposed to be 73. And so what do we know about that? Well, we've counted for 23, 19, and 24. So that's what 16, so 66. So we've accounted for 66 elements. And so then 73 minus 66 is 7. So there are 7 elements that were not yet accounted for. Okay. So 66 were in one of the regions, one of the sets, 7 were not. Okay. The most common mistake is not doing the subtraction. That's like the concept on this problem. So if you're not doing the subtractions, that's like half off. That's like violating order of operations, basically. Or like when you're trying to solve equations and you're like isolating your variable and you're not doing the opposite operation when you're moving terms across, that's how important this subtraction is. Okay. Because for some reason our brains, we often look at that and think that is just A, but that's only A, that's only B. These are not onlys. It's the entire circle. A red flag that you've made that mistake is when you get to the last region and you get a negative number. Like if I hadn't subtracted what is 42 plus 43 plus 19. Yeah, so if you hadn't subtracted, then if you do 42, 43, and 19, that's 104. But there's only 73 in there. So if you do 73 minus 104, you get a negative number because you put more elements in there than the universe contains. And so if you're getting negative numbers out here, that's the red flag. You forgot to subtract. Okay. All right. So now that you filled out the Venn diagram, now you answer the questions. All right. Well, on this one, it's pretty easy because they don't even ask you any tricky sort of questions. They just ask you how many elements are in each region. So region 1, that was our 23. Region 3, that was our 24. And then region 4, that was our 7. Okay. So they're basically asking you to, did you complete the Venn diagram? All right. How many elements belong to set A and how many elements belong to set A and set C? Right. So what is, and remember when we're doing the survey problems, these are not individual elements, it's the number of elements in each region. Okay. So what is besides besides A and C, what is the key word in this sentence? How many elements belong to sets A and B? Or sorry, sets A and C? Well, the key word is and. So what's the difference between and or? Well, and is the intersection. So and is just what they have in common. So again, we're not talking about B, so ignore that circle. So the intersection of A and C is those two middle regions. So it'd be 8 plus 9. So there are 17 elements that belong to A and C. 8 of them only belong to A and C. 9 of them also belong to B. But notice it said nothing about B, so we don't care about that circle. So it's both of those regions. Now, what if that said or? So how many elements belong to set A or set C? Well, or is union, so that's everything in A as well as everything in B. So the or would be 6 plus 4 plus 8 plus 9 plus 1 plus 5. It'd be both of those circles, A as well as C. Okay. So how many elements belong to sets B and C, but not set A? All right. So if we want B and C, that's the overlap of B and C. So it's those two regions. So it's the 4 and the 7, but not A. Now notice it specifically says not A, whereas the last one just said sets A and C. It didn't say anything about B. Okay. But here it's B and C, but not A. So it's not the 4 and the 7 because we don't want the 4. So this would be just 7. All right. And then the last one is a 3-set Venn diagram that we have to fill out. And I guarantee you'll have one of these on the test. Okay. And if this is feeling a little bit too basic, that's not a bad thing. That means that you're kind of getting all this internalized, which is why we did all the homework. The other thing is, in the past, I used to cover just chapter 2 and not chapter 3. That'll be in the next test. And so when I did that is I did like a deeper dive into chapter 2. And so we would definitely have done more complicated chapter 2 problems. But since we're doing chapters 2 and 3, which are both kind of logic, I'm kind of like skimming the surface a little bit of both. All right. So what are we going to do with this? Let me get all these numbers wrote down and then we'll go to document K. All right, so the number universe is 4. Also A is 23. B is also 23. C is 26. Okay. Intersection B is 10. Intersection of A and C, 16. Intersection of B and C is 15. And they tell us the middle is region 7. So notice here on the questions, this one is basically, to answer this question, you have to fill out the Venn diagram. Okay. Let's go to document camera and do that. Okay. So when you're filling out a Venn diagram, particularly a 3-set Venn diagram, you always want to start in the middle, unless they give you weird information, which we're not going to do. Again, those are the more complicated problems. But we're going to start in the middle and work our way out. So we're starting in the middle with all 3, which they already gave us. And now we're going to, that triangle is what I call the trifoil. We're going to do those intersections next. And then we just work outwards. Okay. All right. So what number do we use? Well, the number universe, that's everything. So we can't use that yet because there's what 8 regions total. We only know what 1 is. So we don't know where those 44 go. We only know where 7 of them go so far. A is 23. We can't use that yet because A is that circle. So there are 4 regions there that we are trying to fill in. So there's 3 blank. I don't know where how those 23 get broken up. Same with B, same with C. So we can't use those yet. Now, what about A intersection B? Can we use that yet? Well, A intersection B is those two regions. That's the spots where A and B overlap. So what do we do with that 10? Well, if you put the 10 there, you're telling me there are 10 elements in A and B, but not C. So again, you're making that classic mistake of trying to treat it as an only. This does not say only A and B. It says A and B. So I don't care whether they're in C or not. So there needs to be 10 elements in those two regions. 7 are already accounted for. We need to subtract 7, leaves us with 3. So of the, there's 10 numbers there, or 10 elements, 7 are in C, 3 are not, but total of 10. Yep. So what about A intersection C is 16? Well, A intersection C is those two regions. So I need 16 elements in there. I've accounted for 7. There are 9 left. So 9 goes right there. That's good. Now B intersection C, there are those two regions. I've already counted for 7. We need 15. That leaves 8 to go there. But this is what I mean. You start on the inside, work your way out, subtracting as you go. Because you've got to subtract what you've already accounted for. All right. So let's go back to now. If we look at the number of elements in A is 23. So that circle has 23 elements. I've already accounted for 3, 7, 9 of them. That's 19. And so 23 minus 19 is 4. So there are 4 elements we have not accounted for. So those go only in A. But there's a total of 23. Okay. Same idea with B. B is that whole circle. We know there are 23 total in that circle. We've accounted for 3 and 7 and 8, which is 18. That means 5 are not yet accounted for. And then finally, we do the same with C. C is this whole circle. So we know the number of elements in C is 26. We've accounted for 9, 7, 8, which is what, 21? No. 16 and 8 is 24. So of the 26, we've accounted for 24. So there are 2 left to be just in C. There's a total of 26 in that circle. So are we done? Well, almost, because we have all the regions inside. Now we need the region outside. And this is where, and you may have already, again, if you're forgetting subtract, you may already hit negative numbers in the only regions. But again, if you're getting negative numbers, you forgot to subtract. All right, so we know in the universe, there are 44 elements. Well, how many have we accounted for? Oh, you got to count all these up. Now, I kind of cheat. What I do is I know in A, there's 23. That's where I got that number from. So there's 23, and then I need 5 and 8 and 2. Okay, so that's 10 and 18. So that's 38 that are already accounted for. I need 44. That means there are 6 that are unaccounted for. So 6 goes on the outside. All right, and then this question is just asking how many are in region 1, region 2, region 3, and so on. And you don't have to memorize those numbers because those are always given in the problem. But that's region 1, region 2, region 3. Those will be prominently displayed. They're in MATLAB, so you don't have to memorize those. So basically just answer them in order. They won't ask you region 5 because that was the starting information, but they'll ask you for all the rest of them. Okay, so that is the test. Right, and so just as a recap, the algebra stuff, the inequalities, the exponents, and scientific notation, those are all that's a third of the test. And then another third of the test is the 2, 3, and 2, 4. And then the rest of it is the definition stuff from 2, 1, 2, 2, and then a couple problems with the survey. All right, that's all I have. Hopefully this helped. Like I said, this can be a straightforward test, or it cannot, depending on how well you have studied your definitions and your symbols. So good luck with this test. If you have any questions, email me. And remember, this test is due by this Sunday, which is the 12th. When you're in, let me get into Blackboard here right quick. So when you're in Blackboard, and you go to HonorLock folder, oh no, HonorLock exam list. Yeah, that's showing up. All right. It will say until the 26th, but remember that's for the retest. This 12th is the first attempt. If you don't get it done by the first attempt, you get a 0 for your first attempt. Everybody gets to retest, so you'll have that opportunity. But that's why it says the 26th, is because you get 2 weeks to retest. Uh, and if you were looking, if you had tried to log into the announcement where it had the study guide, for some reason it sent you to, if you got something that sent you to NSU, Northeastern State, all our school, there are several schools around here that are like all in like a Blackboard group, and like NSU is like the lead of that group. So if you are ever trying to get into something Blackboard in my class or somebody else's and it sends you to NSU, let your instructor know, because it seems like there are just random things that get sent there. And so when I had made that attachment for the study guide and sent a part of announcement, for some reason that was sending you to the NSU thing. So it is now in the study resources. And so this one was just like the first one. So first couple of pages have all the dates and stuff. So all the proctoring is just like you did the first test. Most of you are probably taking it home. So that means you're using HonorLock. Some of you are coming to campus. If you're coming to campus, last time, the first test had like an exam with HonorLock and without HonorLock. I didn't need to do that. So there's just one exam to avoid confusion. And if you took the test online the first time and want to come to campus, you're more than welcome to. Or if you took it on campus first time, want to take it via HonorLock this time, not a problem. I don't care how you take it. And I need those dates. If like coming to the ARC Center doesn't work for you because they're during normal business hours, like 8 to 4, and if you're having HonorLock issues, again, I'd be willing to come proctor like after hours, like Thursday evening, which would be my calendar's gone. So Thursday evening would be the 9th or Sunday the 12th. I'd be willing to come to campus and meet with you to proctor an exam. So, but I need at least a couple days notice for that. And if you want to take a paper test, the only way that's an option is if you come to campus and take it. We can't do that online. All right. Oh, and there, exam H, that was just for practicing HonorLock, so that's not on now. If you didn't use it before, maybe if you came to campus or you just had problems with HonorLock and you want to try it again, let me know and I'll turn it on again. But otherwise, I'm not going to have it on because I'm assuming most everybody's been using HonorLock. So we don't need it unless there's specific requirements. What else? Yeah, so Retest, yeah. Actual test is this Sunday by 11:59. Retest 2 weeks. And again, for if you want possibility for partial credit, I mentioned this several times as I was going through here. Write down your work, take pictures, email it to me. And then, or if you're on campus, give it to the exam proctor. And then the other big thing is you are allowed one side of one page of notes of your own. You put anything you want on it. You probably just have to show that you'll have to show that to HonorLock, like flip it over to show that it is just one side. And that'll take care of that. If you have any problems with HonorLock, do their tech support. They have good tech support. And then all the content there that I talked about. So, all right. I guess I could have went over that before I did the full view, but anyway, good luck. If you have any questions, let me know.